Integration by parts, which is an important method in helping us do the calculation when it comes to complicated integrals. Suppose u and v are differentiable functions, then the integral of u dv can be broken down into uv minus the integral of v du. So the most important part is to identify u and dv, so we make the integral simpler, not more complicated. For example, one of the popular question in applying this technique is x e to the x. In this case, let us take u to be x. Then du is equal to dx. Now, if you take dv to be e to the x dx, and then take the integral of both sides, v becomes e to the x. So dv is e to the x dx, and when you're taking the integral, v becomes e to the x, a simpler function to work with. So your integral x e to the x dx, which is u dv, can be written as uv minus integral v du, which we already know how to deal with. This in turn is equal to x e to the x minus e to the x plus constant of integration. The integral of e to the x dx is e to the x. So we're basically done with calculating the integral of x e to the x. Another popular type of integrals that we're using integration by parts is x sine x dx, or x cosine x, or functions of that type. So you have a linear function, quadratic function, a function in power 3, and so on, multiplied by 3, and multiplied by trigonometric functions, or exponential functions, or ln. Those types can be solved using integration by parts. So let us take u to be x, then du is equal to dx. Then take dv to be sine x dx. Then take the integral of both sides. The integral of dv is equal to the integral of sine x dx. So v becomes a simpler function, which is negative cosine x. So in applying the integration by parts method, the integral of x sine x dx, which is u dv, can be written as uv, which is x times negative cosine x, minus the integral of v du. V is negative cosine x, and du is dx. So again, this integral is very easy to work with. So remember that in the method of integration by parts, we want to simplify the integral into the integral that is familiar to us. In turns, it's equal to negative x cosine x, and then taking the integral of negative cosine x becomes sine x plus constant of integration. Another popular question that can be solved using integration by parts is the integral of ln of x dx. So in order to take the integral of ln of x, we're going to use the integration by parts method. Let us take u to be ln of x, then du is equal to 1 over x dx. Now take dv to be dx itself. So if you take the integral of both sides, v becomes x. Very good. So let us set up the integral. The integral of ln of x dx is equal to x ln of x, which is uv, minus the integral of v du. V is x. Du is dx divided by x. So you can get rid of x and x. This integral is equal to x ln of x minus the integral of dx. which can be easily solved as x ln of x minus x plus constant of integration. Remember that we can always take the derivative of right-hand side and show that the derivative of x ln of x minus x plus c is nothing but ln of x, the integrand inside the integral. So as you can see, using the method of integration by parts is very easy when we know which quantity, which function to be taken as u or dv. So my suggestion for students usually is when you start taking the integral using integration by parts, if the integral becomes more complicated at this step, it means that you made a mistake in taking u and dv. It means that you have to go back up and then adjust your selection.